All work connected with track renewal demands seasoned timber. At one LMS depot, 400,000 sleepers and 250,000 feet of timber, mostly Douglas and Baltic fir, are handled in a year. To help creosote impregnation with Douglas fir, small incisive knives on revolving drums pierce the hardened skin of this class of wood. Adzing machines ensure a uniform thickness and a true and level bed for the chairs. Six holes for the chair screw fastenings are bored automatically in one movement. Stacked on special trolleys, sleepers are pushed into the creosoting cylinder. Special clamps seal the door. Valves admit the creosote, and steam is injected under pressure to raise the temperature of it. The pressure is 150 to 200 pounds to the square inch, and the temperature 180 to 200 degrees Fahrenheit. After creosoting, the sleepers are chaired, while timbers are dispatched to the switch and crossing manufacturer. First, the chairs are ferruled. At the chairing benches, screws are driven in by hammer just enough to bite, and the machine, driving 6 screws simultaneously, does the rest. The sleepers are loaded to track or to manufacturers. With every junction due for renewal, steps are taken to see whether or not improvement can be made in the layout. An accurate survey is the basis of any such improvement. From the survey line, measurements are taken to selected points on the permanent way. Carefully logged and tabled under their respective positions on a sketch plan, these measurements and dimensions form the basis on which a full range of drawings is prepared, including detailed working drawings for use by the manufacturers. At the manufacturers, a site is chosen in the yard for laying down the work in as complete a form as possible. When the site has been selected, the baseline, established in the preparation of the working drawings, is laid down using a theodolite to ensure accuracy. It is from this baseline that all dimensions for setting out the work are taken. Pegs are driven in at suitable points, and a string line attached to the pegs from which measurements are taken. Creosoted timbers are selected and stacked alongside the work. They are laid down on the site in the positions indicated by the working drawings and are all ready to receive the switch and crossing units. In the foundry, the chairs are being cast. A wood or metal pattern is made for each type of chair. It is placed in a metal box and sand packed round it. When the sand has been made firm round the mold, the molding box is turned over. The pattern is removed, leaving a void in the sand, the shape of the chair to be cast. In casting, it's what isn't there that matters. A cover plate fits onto the box. Molten metal is poured in until the void is completely filled. And when the metal has cooled, the molding box is stripped and the chair removed and taken to the fettling bench for cleaning and fettling. All burrs, sand and other unnecessary excrescences are removed from the chair. In addition to ordinary track chairs, other types for switches and crossings are cast in a similar manner. Chairs selected at random are gauged. Gauges determine the distance between fastening holes. Center line of rail seat from inside holes. Tilt of rail in chair, and interval between chair jaws. Sample chairs are put to a braking test. The braking load in this case was about 27 tons. Actually, the specification requires a braking load of 19 tons. Straightening rails in the bending machine is the first job in the machine shop. They are then cut into lengths for making into switches and crossings. For crossings, rails are bent to the required angle and corrected for tilt. In making the extension of the bottom table of the point rail to take the holding down bolt, the web is drilled. The 3-inch piece of the head and web is taken out by saw, leaving the bottom table in position. To form a V for a common crossing, one rail is spliced into another. Material from the point rail is cut out to form this splice, and the splice rail machined so that it fits into the recess. Both point and splice rails are twisted to the requisite inclination, and they are then fitted together and bolted. The feeler shows that a good splice has been made. Top and side planing completes the V. The nose is gauged for profile and the fit of the splice examined. This is the new standard A type chair adopted by the LMS. The advantages of this type over the old are that the shear on the chair bolt is reduced and the holding down bolt is much more readily maintained. After the machining and assembly of the switch and crossing rails, these components are assembled in the yard. The switches are fitted up to the stock rails, chairs are brought from the foundry and fitted on the rails and keyed up. Switch anchors are fitted between the switch and stock rails and bolted in position. The completed switches are loaded up and transported to the site in the yard for assembly into junction work. A crane unloads the units and places them on the timbers in their positions, which are determined by measurements with a steel tape. The crossings are similarly assembled into units. This one is a special one known as a fiddleback. The whole unit is transported on a man-handled trolley, its position again being accurately located by the use of a steel tape. So each switch and crossing unit is dealt with, each one fitting neatly into its position in the layout as defined on the drawing. Throughout the work, a careful check is maintained with a track gauge to ensure that, as the rails are fitted into position, a minimum of effort is required to assemble the several parts. The junction is beginning to take shape, and the work progresses steadily. Careful planning and constant checking is evidenced by the ease with which closure rails are laid down in the chairs and located on the timbers. Squaring up switches and crossings is regularly carried out to ensure their proper location. And when in position, the keys are driven home. Next job is the work of lining up the chairs for the opposite rails. Closure rails are placed in the chairs, fish plates and fish bolts fitted at the joints, and the felts placed under the chairs, the track being eased up slightly off the timbers to enable this to be done. Where it is necessary for ferrules to be inserted in the chairs, a dolly cup is used for driving them. Holes for the chair screws are made with electrically driven boring bits. Screws are driven, but not with a hammer, if you please. They should be driven into the timber sufficiently to obtain a bite, and then screwed home with the electrically driven screwing machine. Where junction work is assembled in a manufacturer's yard, it is of course essential to ensure that the several parts shall be readily located when it arrives at the actual site. All timbers and rails are numbered, starting at one end of the junction, the numbers being painted on both the rails and the timbers. The spacing of the timbers is ensured by using wood laths. Those on one side of the track are painted white, and those on the other black. The center lines of the timbers are painted on the laths. In case the painted lines become obliterated by wet, galvanized nails are driven into the timbers on each side of the laths. Each lath is indexed with a letter at the ends. Where the chairs are to be removed from the timbers, a white line is painted round the base. The lateral location of the timbers on the relaying site is determined by a white line, established if possible throughout the whole length of the work. The line is set out with a theodolite and white marker. The work of marking appears to be a tedious one, but the valuable time saved and the accuracy secured on the actual site makes it very much worthwhile. The job completed, the smooth riding of a trolley gives impressive evidence of the accuracy of the work. The completed work is inspected by the district staff who will be responsible for the renewals. Each component is loaded up in ordered sequence, so that on the relaying site they are in their proper order, ready to be dropped into position. Switches and crossings are loaded up first, the white and black strips tied up in bundles, and the screws and keys taken out and put into bags. Rails and other components follow, the wagons being marked to establish their position on the relaying site. Where it is necessary to remove the chairs, the pads are nailed down. The preparatory work on the relaying site of taking out the old ballast and preparing the wagons for unloading is done prior to the day for the renewals to start. Preparatory work reduces to a minimum the time of occupation of track on the appointed day. The appointed day for renewals arrives. The old material has been partly lifted and the first timbers for the new work are being laid down. The steam crane is employed to the fullest extent on this class of work. The track broken, the usual Sunday renewal weather starts. Yes, it is rain. When the first lot of timbers have been laid down in their approximate positions, they are adjusted to re-establish the white line. That is to say, they are positioned laterally. Afterwards, the white and black strips are nailed onto the timbers to position them to their proper spacing. When the strips and white line have been established, the switch units can be lowered by crane and placed in their final position on the timbers. The work of coupling up with fish plates and fish bolts is carried on continuously. From time to time, slight adjustments to track may have to be made to put it all in its final position. When all fastenings have been screwed down into position, the job is finished. Despite the weather, the work has been carried out according to plan. Track has been occupied for a minimum of time and the first train passes sweetly over the renewed connections.